Hello everyone and welcome back to science class. I hope you had a really good rest over the holidays and that you've come back fresh to learn about science. So, before we left for the holidays, we started a new topic and I wanted to spend some time to just review that new topic before we moved on to the next thing. So, as we learned, everything is made up of atoms. Now, atoms are incredibly small particles that no one has ever seen. We cannot see atoms because they're so tiny and so small. Now, atoms are made up of even smaller particles called protons, neutrons, and electrons. And we often draw them in a diagram similar to what you see here. So you see here in the middle, you have your protons and your neutrons. And then floating around the outside, you have the electrons. So we know that there are 118 different types of atoms that exist in nature, or that exist in general. Some of them are not necessarily found in nature, but we managed to create them. But we know that there are 118 atoms, and so we also call them elements, and we organize them in what we call the periodic table of elements. So we talked about big categories, we talked about smaller categories. Let's talk about that right now. So if we look at this periodic table here, you'll notice that I have some labels on it. I don't know if you could read it from there, but I have some labels on there. So you'll notice that I've colored in these few boxes here. That is our staircase. That kind of separates the table. On the left side of the staircase are all of the metals, except for that one right there. That's a non-metal. Everything to the right of the staircase is a non-metal. And everything that's on the staircase is kind of like an in-between. It's called a metalloid. Now, if we remember, metals conduct heat very well and electricity very well, and they also react with acid. Non-metals are basically the opposite. They don't conduct heat, they don't conduct electricity, and they don't react well with acid. Metalloids are kind of in the middle. They have some properties of metals and some properties of non-metals. The important thing that you need to remember about metalloids is that they are called semiconductors, which means that they can conduct electricity, but they can also resist electricity, which makes them really useful when using them in things like the camera I'm filming with, or my phone, or my laptop. Not only is the periodic table organized into three main categories, it's also organized into something called periods. That's pretty much why it's called the periodic table of elements, because it's organized in periods. Now, the periods are the rows of the periodic table. They're the things that go left to right. So I've colored all of my different rows, and if you look carefully, you will see that there are 7 different periods. Now, when we count periods, we always start from the top of the table and count our way down. So the pink row is period 1, the blue row is period 2, the yellow row is period 3, and so on and so on. Now you'll also notice that when we get down to here, we have 2 green lines and 2 red lines. That's because all of these guys fit in here. But there was not enough space to show all of these guys in the same lines, so we have taken that chunk and put it down below. Now the important thing that we need to remember about the periods is that the number of the period corresponds to the number of electron rings around the nucleus in an atom. Let's take a look at an example. If an atom is located in period 4, then it will have 4 electron rings. Now, potassium is located in period 4 right here. And I've drawn out the model that we would use for the potassium atom. And you can see that it has this small ring in here. That's the first one. Then there's a second ring, third ring, and the fourth ring. This is what we mean by the rings. So any atom that's located in period 4 would look very similar to this. It would have 4 rings. The last type of grouping that we're going to look at with the periodic table are the groups. You can see that these are the colored columns that I've put on this table here. Now, we're only really concerned with these groups here. There are other groups in the table, such as the ones in the middle and the ones in the bottom here, but we're not worrying about those ones. Specifically, we're also just going to be taking a couple of these ones to look at. We're going to look at the first 2 in detail and the last 2 in detail. So group 1 is the blue column right here. Those are the alkali metals. They're the most reactive metals that you'll ever find in the table. Then we have the yellow column. The yellow column are still pretty reactive metals, but they're not as crazy intense as the blue ones right here. On this side here, we have our brown column, which are the halogens, and those are extremely reactive and extremely volatile nonmetals. Last but not least, we have the red column right here. Those are our noble gases, and the thing that's special about these ones is that they don't react at all. They are completely non-reactive. Now the groups correspond to the number of valence electrons that an atom has. The valence electrons are the electrons located on the outermost shell. So if we were to take a look at carbon, carbon is located in group 4. If we look here, carbon is in the orange column right there. If it's in group 4, that means that it has 4 valence electrons. And this is drawn using a simplified version of our model that we're going to be seeing. So we just have C for carbon, and then we draw the 4 valence electrons as dots around the C. Now I know the periodic table can be a little intimidating because there's so many ways that we group things on the periodic table, and there are so many elements. How can I remember them all? Well, the thing is that I'm not asking you to remember them. All I'm asking you to remember are the metals, nonmetals and metalloids, and the groups and periods. That is it. Period. Until next time.